Can anyone tell us which formula for differentiation? What type of function is it? Once we know what the type of function, then we know which formula to apply. Which differentiation rule are we going to apply on 10 t squared e to negative t?
Is it the same one we just used, where it's e to the power of
right,
f of x
but
and times
absolutely. But first I have to identify what type of function it is. So I know which formula to apply. So what is it?
It's exponential.
A piece of it. What type of function is it before we look at the exponential? We need to identify that. I don't know which rule to apply before I identify the function. Yes, this is exponential.
Product?
Yes, absolutely. I have to identify the fact that this is a product, the product rule. Yes, absolutely. Thank you. Good. So what I recommend with this product is leave the 10 outside, differentiate t squared, and we have 2t e to negative t plus t squared e to negative t times negative 1. So first we need to identify and realize that this is a product, so I need to apply the product rule. I will simplify it. As 10, I factor out e to negative t, and let's see what we have inside. We have 2t minus t squared. And yes, I can also factor out a t, but that's, for now, it's good enough. We're not going to do anything else with it. We're just going to plug in. So now, in the graphing calculator, I put c of x, and I also put c prime of x. Although with c prime, I'm only interested in 5, I will calculate all of them, since I'm going to have them right there. So in y equals, clear everything, and put those two functions in. The first one is 10 t squared e to negative t and the other one is 10 e to negative t and in parentheses 2t minus t squared. Good. So now I have second table, and I want 0, it's right there. I want 1, I want 2, I want 3, I want 5, and I want 10. Okay, so 0, 3.68, 5.1, 4.49, 1.68, and 0.05. Okay, for C prime I have 0, 3.68, I have 0, negative 1.49, negative 1.01, and negative 0.036. Good, so I fill out the table. I determined the concentration. I will graph the function, and now we're going to simply interpret C of 5 and C prime of 5. But first, let's also graph. So I'm going to go to y equals, and I'm going to clear this one, or not clear it, but at least de-highlight it, because I don't want to graph the derivative. I only want to graph the function. And I will go to this viewing window and change it as they want us to do, to change it from 0 to 10. with a scale of 2. That's what they wanted. They wanted 0 to 10, correct? Yes. I don't know how high. I see the 10. Okay, so y minimum 0 and y maximum not too much, 5, maybe 6, with a scale of 1. And here the graph. So this is the graph of C of t between 0 and 10. And we have the peak is at roughly about 2, at 5.4. So we graph that. Now let's also talk about what they want us to talk about, which is this. I know I have 2 more minutes. So this is the concentration at the time. I just want to see again, the time was in hours on this one. Okay. So the concentration at 5 hours. So we take the medication. We take the medication right now. 5 hours later, the concentration in the bloodstream is 1.68 parts per million. Now, what does C prime of 5? C prime of 5 is negative 1.01. This is how fast the concentration is decreasing at 5 hours. So the actual concentration in the bloodstream was 1.68 parts per million. At that moment, 5 hours after we took the medication, the concentration in the bloodstream at that moment is decreasing by 1.01 parts per million. That's the difference between these two. CO5 is what was remaining in the bloodstream after 5 hours after we took the medication. C prime is how fast is the rate of change. So the measurement unit here is parts per million. The measurement unit here is parts per million per hour, because it's C prime. This is in parts per million. That's the concentration in the bloodstream. But C prime at 5 is parts per million per hour, which is how fast is the concentration in the bloodstream decreasing at that moment. So this is the distance, in other words, that we have to cover. And this is how fast we are going 5 hours later, as an analogy with distance, rate, and time. What is the distance and how fast we're going 5 hours later. So we completed 2.1 and 2.2. I did not get the chance